Hello and welcome to Arithmetica and the fourth video in our presentation of proof and reasoning. In the previous video in this series, we introduced the topic of inductive logic before finishing with a couple of examples. In this video, we continue from where we left off and provide another two examples of inductive inference. As in the previous video, we shall present the inference in syllogistic form. Suppose a medical pharmaceutical company has developed a new drug. As part of a mammoth undertaking, they have collected results obtained from a vast number of volunteer test subjects of various ages and races. The selection process is regarded as being sufficiently random and of a comparatively large sample of the world population. There were a number of interesting results obtained from these statistics. In particular, only 20% of the volunteers had any ill side effects, none of which were regarded as serious. The scientists conclude that for any person taking this drug, there would only be a 20% chance of any ill side effects, none of which would be expected to be of any serious concern. So does this seem to be a reasonable conclusion? Well, it certainly seems compelling. So let's take a closer look. The logical inference goes something like this. We shall take the major premise to be, as part of a drugs trial, data is obtained from volunteer test subjects of a comparatively large random sample of the world population. And the minor premise as only 20% of the volunteers show ill side effects after taking the drug. We can then induce that, therefore, it is highly likely that any person taking this drug will have a 20% chance of any ill side effects. For clarity, we include the phrase "it is highly likely" in the conclusion. This is because it follows by induction as opposed, say, by deduction. We cannot be certain that only 20% of the world population would suffer from any ill side effects, but because we are told that these statistics has been taken from a comparatively large random sample of the world population, it carries with it a good statistical viability. The main components here is the largeness of the sample size and of course that it was randomly selected. The randomization tells us that it is non-biased and should be a good representation of the overall population. Thus, this example of inductive inference would be categorized as strong, since there would be a very high probability of the conclusion being true. Of course, in reality, such a mammoth undertaking will likely be unrealistic, and a company would need to consider the cost-to-benefit ratio of such an endeavour, together with any additional funding they might have received, as well as any outside help from other organisations. This approach to induction is often called induction by generalisation, and for obvious reasons. It is a common feature in inductive arguments, and which interestingly contrasts to that of deductive logic. A deductive inference has the typical structure of deriving a specific case from a generalization or rule, while an inductive inference includes the type of structure that allows one to derive a generalization from a specific case or cases. The more cases that occur in an inductive inference, then the stronger the probability of the conclusion being true. The induction is made even more stronger if the specific cases are unbiased. This is normally achieved in statistics by choosing a random sample of the population of interest. For our next and final example, we consider an inductive generalization that would be regarded as weak. Suppose you are busy clearing out the attic, and you discover a fairly large heavy bag of coins. You proceed to empty out some of the contents into a small pile onto the floor, say 5 coins, and observe that they are all copper coins. From this you conclude, without looking inside the bag, that it likely consists only of copper coins. As before, this seems perfectly reasonable. The formality of the inference could go something like this. Let the major premise be: a large heavy bag consisting of coins has been discovered. And we shall have the minor premise as: a small number of the coins have been emptied out, all of which have been found to be copper. We can then inductively infer that, therefore, it is possible that the bag contains only of copper coins. As in the previous example, this has the form of induction by generalization. However, because of the comparatively small sample size, it is by no means certain that it is truly representative of the bag's entire contents. The sample size is just too small to yield a strong likelihood, and so results in a weak inductive inference. It might not take too much effort to rummage around in the bag and pull out another type of coin made by metals other than copper. There is even the question of whether the selection is not biased in some way. How do we know if the selection was sufficiently randomized? If, say, you only taken out 5 coins from the top of the bag, then we have a better impression of the coins located at the top than of any other coins distributed throughout the bag. Thus, the selection could be highly biased. Thank you for watching the second part of our introduction to inductive inference, such that, together with the various examples of induction, it is hoped that it has functioned well in providing sufficient understanding. In the next video in the series, we shall be introducing Arithmetica's presentation in another form of logical inference called abduction. And so, until next time, it's goodbye from Arithmetica.